Hello everyone, welcome to Coding Autos. So today we will see how to implement stack using array. So what is stack actually? Stack is a data structure which is last in first out. It follows last in first out structure. Whatever the element we push at the end, we remove that element first. Okay, so suppose we are pushing 1 2 3 4 5 inside the stack one by one, then um, first element coming out will be 5, then 4 will come out, then 3 will come out, then 2 will come out, and at the end 1 will come out. That is why it is called as last in first out data structure. Okay, so let us understand it in detail. So while implementing stack, um, we will need a few operations to be performed. Like to push an element inside the stack, we will need push operation. To pull out the element from the stack, we will need pop operation. To find the element which is present on the top of the stack, we will need um, peek operation. So this is just a name which I have given. I can give any name. I can even write here top as the name of the function to find the top element of the stack. We can also find whether the element is empty or not. So the code for the respective functions are written over here. So I can find them. We can use any functions. These are the custom implementation of the function. Uh, as of now, I just want to push the element inside the stack, pull the element outside from the stack, and then find the top element from the stack, and also need to find whether the stack is empty or not. So that is why I've written just four functions inside a stack. If you want to perform any other operation, we can write the implementation of that function inside the class, and then we can call that function by making object of the class. Okay, so for now we will see push, pop, peek, and empty function inside the stack. Okay, so to implement stack, we will use a class named as stack. We can give any name to the class. Okay, and these are the properties of the stack. We will take three properties: top, size, and the pointer to the array. As we are implementing the stack using array, so we will make an integer pointer which will point to the location of the array. Okay, so these are the properties of the class stack, and then we will use a constructor. Okay, so this is a constructor. Constructor will not have any return type, or it will not return any value. So its name will be same as the name of the class. Now I am writing a parameterized constructor. So whenever we create an object of the class, this constructor will be called. Okay, so initially this is our int main function from where the function execution will start. I have declared a variable size, and I'm taking the input from the user. Then I am making an object named as s of the class stack, and I'm passing a parameter size. Okay, so I'm passing a parameter size. Once this line is being called, once the object has been created, it will go inside the stack class, and then constructor will be called. Okay, so as we have passed some value inside the size, it will take this size and then initialize our object with that size. This arrow size means the object which is calling this class. For that object, the properties of that object, all the properties of that object will be top, size, and um, pointer. Okay, so we will give that object this size. The top of that object will be initialized with -1, and we will create a new array. Dynamically, we are creating an array, and this array, dynamically created array, will return a pointer. So we will catch that pointer, and it will be stored in ARR. Okay, as it is a pointer. So this initialization of the stack has been completed. Now as the stack has been initiated, it is initially an empty stack, so top is -1. Its size will be given to us, and that memory location will be created having this much amount of size, and ARR is pointing to that stack. Okay, now we have to perform some operations on the stack. So operations which have to be performed is push operation. At the first we will perform push operation or pop or anything. So first we will see the implementation of push. So as we need to push an element inside the stack, we need an element which we have to push. So we are passing an element which we want to push over here. So how will we pass it? In the int main function, we will just write s dot push, and the element which we want to push, s is an object and push is the function which we are creating. So and we are passing an element 11. Okay, so this 11 will go to the element. Now for pushing we need to see whether our stack is full or not. So to check this we need to check whether where is our top. So initially top will be at -1, means the stack is completely empty. Now when the top is greater than or um, equal to size -1, that greater than equal to size -1 means the stack is completely full, and now we are trying to push one more element inside the stack, which is not possible when the array is already full. How can we push an element inside the stack? So we need to check this condition whether the top is greater than or equal to size -1. If it is, then we cannot push an element inside the stack. So um, we simply output an statement saying that stack is overflowing, so we cannot push an element inside the stack. And if this is not true, if top is not greater than or equal to size -1, then we will increment the top by 1, because the top is initially at -1 level. So and the indices of the array, as we know, is from 0 to size -1. Okay, so we will increment it. If initially there are no elements present in the array or stack, then we will increment it. The index will point to 0 as we have incremented the top. So now top will point to 0. Now at the 0th position we will insert this element. Okay, or wherever the top is, if the top is at 1, it will increment to 2, and this element will be placed over there. Okay, after this element is placed, um, that's it, our push operation has been performed successfully. So wherever our top is, at that particular position an element will be present. Okay, an element will be present over there. So to push an element we need to increment the top, so that at that point, at that place, no element would be present and we can push our element over there. So whenever we need to push an element, we need to increment the top and then push it. Hmm. Okay, so this was the push operation. Now let's see pop operation. So same as the case in push, as we were checking whether the stack is full or not. In case of pop, we will see whether the element is um, empty or not, whether the stack is empty or not. How can we check this? If the top is equal to -1, that is no elements are present, then how can we pop any element from the stack? So we will check it that whether top is equal to -1. If it is equal to -1, then stack is underflowing, and if there is no element, how can we uh, pull out an element from the stack? So simply we will say this. And if there are if there is some element inside the stack, then that top will be pointing to that element, so we will simply decrement the top. Okay, um, if suppose top is pointing to an element 22 which is present in index 2, then we will decrement the top by 1. Now the top will point to an index 1. So uh, now the track of that element is lost, and whenever we want to push an element, we will increment the top by 1, and that 22 will get replaced by the new element which has been pushed. So why are we decrementing the top over here? Because we don't want to keep a track of that element. Okay, that element will be there, but when we will decrement the top will be pointing to that other element, and for us that particular element will be our top, and no other element will exist in front of that. If for us, but it would be present, but our top will point to only that position which for us would be the top of the element, top of the stack. Okay, and whenever we want to push an element, top will be incremented, there 22 will be there, but we will, why are we incrementing the top? We are incrementing the top because we have to push an element inside it. Okay, so 22 will be replaced by some another element which would be added. Okay, so this is all about the pop function. Now let's see the peek function which I've created. So peek function, what it does is it returns the topmost element of the stack. So first we have to check the condition whether we are in that condition to return the topmost element of the stack or not, because the stack could be an empty. If stack is empty, then how could we return an topmost element? Okay, so if top is equal to -1, we will return that stack is empty, or else if the top is any value which is greater than equal to 0, we will simply return an element which is present on the top index. Okay, so this is about the peek function. Now let's see the empty function. Empty function checks whether the um, stack is empty or not. If the stack is empty, that is if top is equal to -1, it will return true, else it will return false. The return type is bool, that's why we are using true and false. Okay, that's it. These are the four functions which we have implemented in the stack class. Okay, now we can call these functions from our int main. Okay, and I have declared these properties as public, so we can access it outside also. These properties as well as the behavior of the functions, I have declared it as public, so we can access it outside the function, outside the class as well. That's why we are able to access push, empty, pop, or any of the functions outside the class. So we are able to do it. Now let's see. Now let's run this code and see. Okay, so initially, okay, I need to give the size. 5 is the size. Okay, so as you can see, I'm pushing 11 at the first, then I'm pushing 22, 33, 44, 55. Okay, so the topmost element will be 55, which I can see over here. Then I'm popping one element. Okay, after popping the element, the topmost element will be 44. Then I'm again requesting to show the topmost element. Now the topmost element will be 44. That's it. In this way, we can see how the functions are working. We can even call empty function. I have also written over here, if it is empty, I will say that the stack is empty. At the start, I have pushed 11, so it is saying that the stack is not empty. If I would have called this function um, before this statement at as dot push, then the stack would have been empty. Okay, so I hope you have understood this method of implementing the stack using array. Okay, now there's one more way to implement the stack. We can use STL. By doing STL, we can also implement it. So let's see that also. So to use STL, uh, to directly implement the stack using STL, we have to include stack. So we are including stack over here, and we need to create a stack. So there is already using STL we can create stack like this. So this says that we want to build a stack which should contain all the integers inside it, and we are calling that stack as S. Now we can use the push, pop, empty functions, top function which is predefined inside the stack STL, so we can directly use it. You can refer anywhere. So push, pop, top, empty, all these are the functions of the stack which are predefined, so we can directly use it. And all these functions which are already present over there, they are already optimized a lot, so we can directly use it. But inside in your interviews, avoid using it because they don't allow using STL or allow using direct functions to solve any problem. Okay, so at that time you can show these method to your interviewer or in your coding assessment, and your work will be done. Okay, so this is about STL, how you can implement stack using STL. Okay. Okay, so now let's see one question. So let's see this question. In this question, we need to implement two stacks. inside a single array. So how can we implement two stack inside single array, and the size of the array will be given to us. Okay, the size of the array will be given to us, and we need to implement two stacks in a single array. So what we can do is, um we can start one of the stack from the right hand side of the array, and the next stack from the left hand side of the array, and start filling the first stack from left to right, and start filling the second stack from right to left. Okay, so this is the approach which we will be using. And until there is a space inside the array, we will keep on adding the elements, whichever it is, whether it belongs to stack 1 or stack 2. We will keep on adding the elements until there is space inside the array. Okay, so as we need to perform some operations inside it. We need to push the elements inside the stack, both of the stacks. We need to pop the elements from both of the stacks, so we need to write the functions for them. So I've already solved it. So we will be making a class will be already given to us inside this question. These are some attributes or properties which I have mentioned. The stack 1 will have a top, stack 2 will have a top, and the size is fixed because array is only one, and the pointer it is a pointer to an array which is already given. Okay, so this is a constructor in which we will initialize, initially the top one will be -1, and the top two will be size. Okay, um, the size it will contain, okay, size will remain whatever we have given over here. We will give the size as that only, and we will create the memory, that much amount of memory, and AR will point to that. Okay, now we'll write the push function for the stack 1, which will start from the left hand side. So first of all, we need to check whether there is space inside the array or not. So to do this, we will simply subtract top 2 minus top 1, and if that top 2 minus top 1 is greater than 1, okay, if top 2 minus top 1 is greater than 1, which means that there is at least one space present inside the array, so we could push an element in stack 1. Okay, so we will increment the top by 1, and we will push the element given inside the array. Okay, at top 1 index we will push the element num inside the array. Okay, now let's see the second push function, which we are implementing for stack 2. So the second stack will start from the right hand side. Okay, so here also we need to check whether there is an empty space or not. So top 2 minus top 1 should be greater than 1. Now when there is an empty space, what we will do, we have to decrement the top, as we are starting from as we are starting from right hand side and moving towards the left hand side. So the space will be um, present towards the left hand side, so we need to decrement the top. Okay, so whenever we decrement the top two, we will be pointing towards the empty space. So now at that particular index, top two will be pointing, and at that index we will put an element num. Okay, so this is about push to. Now if we want to pop an element from the first stack, we will check whether the top is equal to -1 or not. If it is equal to -1, so no element is present in the first stack, so we will return -1, because in the question it is saying that we need to return -1. Okay, so as the question says, we are returning -1 because we cannot pop an element from the empty stack. And if the element is there inside the stack 1, what we will do, we will what the question is saying that we need to return the popped element. Okay, we also need to return the pop element. So at whatever position top one is pointing, we will first take that element and place it inside an variable popped, and then we will decrement the top one. Okay, now we will return the pop element. That's it. Now the second pop function, we will see whether the top 2 is equal to size. Okay, if top 2 is equal to size, which means that the top 2 is pointing outside of the array. which means there is no element present in stack 2. If there is no element present in stack 2, we cannot pop an element, so we'll return -1 according to the question given. Or else if there is an element present in it, we will take that element, put it inside popped, and then increment the top 2. Okay, when we increment top 2, it means that we have popped an element from the stack 2. Okay, now we will return the popped element. Okay, so this is about um two pushes and two pops which are being performed on the two stacks which are present in same array. Okay, so this is it. This is the second way in which I have solved the question. So this is okay, this is fine, this will work for you. Let's run this. All the test cases are passing. I've already submitted it, but yet once more let's submit it. So yes, all the test cases are passed and we have successfully submitted it. We have performed better than 90% of people. So that's it. That's all about today. We have seen how to implement the stack using array, and we have also solved one question on it. We have seen STL implementation also. So that's it for today. If you have any doubt, you can ask me in the comment section below. In the next lecture, we will see how to implement stack using linked list. So stay tuned for that. So that's it for today. Thanks for watching and bye bye.